Assalamualaikum dan salam sejahtera. In this video, we will be discussing about lecture 3, geometric sequence and series. First, look at our learning outcome. By the end of this video, students should be able to find the n term of geometric sequences and series. Tn equal to a times r power of n minus 1, and to use the sum formula Sn equal to a times 1 minus r to the power of n over 1 minus r for r not equal to 1. Geometric sequence. A geometric sequence is a sequence of numbers in which any term can be obtained from the previous term by multiplying by a certain number called the common ratio. Okay, this is the example of geometric sequence. So you can go through by your own. Okay, next slide. The general term of geometric sequence Tn equal to a times r to the power of n minus 1. And the common ratio is r equal to second term over first term, or third term over second term, or in general Tn over Tn minus 1. Okay. Go to example 1. The n term of a sequence is Tn equal to 5 times 3 over 2 to the power of n minus 1. Find the value of n where Tn equal to 1 to 1.5 over 32. Okay, next we discuss the solution example 1. So, okay. So the question given Tn equal 5 times 3 over 2 to the power of n minus 1. Okay. Next, find the value of n where Tn equal to 1 to 1.5 over 32. Okay, to find the value of n, substitute Tn. So 5 times 3 over 2 to the power of n minus 1 equal 1 to 1.5 over 32. Okay, next bring 5 to the right. 3 over 2 to the power of n minus 1. So we get 1 to 1.5 over 5 times 32. Okay, simplify. So we simplify. We get 3 over 2 to the power of n minus 1 equal to, okay, 1 to 1.5 over 5 is 243 over 32. Okay. First, we change the base to 3 over 2. We change base 3 over 2 of n minus 1. Okay, change base 3 over 2. So 3 over 2 power 3/2 power 5. Okay, 3/2 to the power 5. Okay, next, compare the index for both sides. Okay, compare the index. So left hand side is n minus 1 equal to right hand side 5. Then we get the value of n equal to 6. Okay, settle for example 1. Next slide, we go to the sum of the first n term of geometric series. There are two formula for r less than 1, Sn equal to a times 1 minus r to the power of n over 1 minus r, and r not equal to 1. And second formula for r greater than 1, Sn equal to a times r power of n minus 1 over r minus 1, and r not equal to 1. Okay. Next we go to example 2. Question example 2. Okay, the sum of the first system of a GP or geometric progression is 9 times the sum of the first 3 terms. Find the common ratio. Okay, we discuss the solution example 2. The question given the sum of the first system S6 equal to 9 times the sum of the first 3 terms. Okay. There are two formula. You can choose one of them. Okay. So I choose the second formula. Okay, the second formula, A times r power of 6 S6 r power of 6 minus 1 over r minus 1 equal to 9 times S3 is A r power of 3 minus 1 over r minus 1. Okay. Next we simplify. Okay, you can cancel this r minus 1. Okay. So we get r power of 6 minus 1 equal to 9 r power of 3 minus 1. Then bring r power of 6 minus 1 to the right hand side. We get 9 times r power of 3 minus 1 minus r power 6 minus 1 equal to 0. Okay. Then factorize r power 6 minus 1. 9 times r power 3 minus 1 okay, minus, so factorize r power 6 minus 1, we get r power 3 minus 1 times r power 3 plus 1 equal to 0. Then factor out r power 3 minus 1. 9 minus r power 3 plus 1. equal to 0. Okay, then simplify. R power 3 minus 1, 9 minus R power 3 minus 1, 8 minus R power 3 equal to 0. Okay, then solve the equation. R power 3 minus 1 equal to 0. So R power 3 equal to 1. Then we get R equal to 1. Okay, and second factor, 8 minus R power 3 equal to 0. So R cube equal to 8. We get R is 2. Remember, R not equal to 1. So the answer is R equal to 2. Okay. Next we go to example 3. Example 3. The first term of a geometric sequence is 27 and the common ratio is 4/3. Find the least number of terms the sequence can have if the sum exceeds 550. Okay, next we discuss example, the solution for example 3. The question given the first term A is 27 and the common ratio R is 4/3. Okay, so find the least number of terms the sequence can have if the sum exceed, suppose Sn exceed 550, so Sn more than 550. Okay, then substitute into Sn formula. Substitute into Sn formula. There are two formula for Sn. Okay, then we know the common ratio is 4/3. R more than 1. So we choose this second formula. R for R greater than 1. Substitute into Sn formula. So A times R power of n minus 1 over R minus 1 more than 550. Okay, next substitute A and R. 27 R 4/3 to the power of n minus 1 over 4/3 minus 1 more than 550. Okay, then simplify. After we simplify, we get 4/3 power of n minus 1 more than 550 over 81. Okay, next bring -1 to the right. Get 4/3 power of n more than 550 over 81 plus 1. So 550 over 81 plus 1, we get 4/3 power of n more than 631 over 81. Then taking log for both sides, so log 4/3 to the power of n more than log 631 over 81. Then using rule of log n log 4/3 more than log 631/81. N more than log 631/81 over log 4/3. Then by using calculator, so log 631/81 over log 4/3, we get n more than 7.136. Okay, so the least number of term, the least number of terms is more than 7.136, so is 8. Okay. Okay, so for example 4, the solution is already on your lecture note, so you can go through by your own. Okay, thank you.